Hello, and welcome to a little video about the Unit 6 test review. In 1 through 4, what we're going to do is we're going to complete each statement and write the postulate that we used. Alright, in number 1, I have the measure of something plus the measure of Lm is the measure of something else. Now in the image before me, I'm going to mark Lm. Lm is this right here. And it looks like we're adding. Now, if we're adding line segments, first of all, the postulate is segment addition. I know, creative. But I didn't come up with a name, so don't make fun of me for that. Right, so here we're adding segments. Well, let's add two segments next to each other. The segment that's right next to LM is segment KL. So the measure of KL plus the measure of LM gives us the measure of what? Well, it gives us the measure of this whole line segment, which is KM. Number 2. Here I have the measure of an angle symbol plus a measure of another angle symbol equals the measure of angle WXZ. First and foremost, I'm going to write down the postulate, which, again, not that creative, angle addition. Hey, not creative, but easy to remember because it says exactly what it's doing. Well, what two angles can we add to make WXZ? Well, WXZ is this whole angle, and that is made up of two smaller angles. It's made up of this one, which we can call WXY. That's not a Y, Gumin. Let's try that again. Oh, there we go. And it's also being combined with this tiny angle, which I can call YXZ. YXZ. Perfect. All right, number 3. Once again, I have some angle addition, but let's see what it looks like this time. Here we have the measure of some angle plus a measure of another angle equals 180. Now 180 degrees is the measurement of a line. The postulate is linear pair because it's a pair, which is two angles that create a line. Well, let's see what two angles combined give us 180 degrees. On the left side, I have this angle. Let's call it angle GHI. If you called it IHG, you would have also been correct. On the right side, I have angle IHJ. When I add them, we get 180. All right. In number 4, I have the measure of I have an angle congruent to another angle. Well, this postulate is called the vertical angle postulate. Now I know it doesn't look vertical, these two angles. I'll retrace them with the color so you see these two angles. I know they don't look vertical, but they are straight across from each other. One way I remember this as a student when I was learning these definitions is the vertical angles form two V's. Two little V's touching each other. Vertical. Maybe that helps you. Maybe it doesn't. Hopefully it does. Okay, so the angle on the left here, I'm going to call it angle VW. Well, that's not how you write a W. Let's try that again. VWX. And on the right side, I have angle ZWY. Since they are across from each other like this, they are congruent, which is the geometric way of us saying that they have the same measurement. We don't know the measurement, but we do know it's the same. Okay. Number 5. If ABC forms a linear pair with CBD, let's use the linear pair postulate to determine the value of x. Well, based on number 3, I can write this. I can write angle ABC, or the measure of angle ABC, plus the measure of angle CBD equals 180. Well, ABC is 5x. So instead of ABC, I'm going to write 5x. Plus The measure of CBD is 13x plus 36. 13x plus 36. And it still equals 180. And I think I'm going to zoom in and make this smaller so it fits. I think I wrote it a little too large, but luckily with the magic of, don't let me down here, tablet, the magic of technology. Uh-oh, it's letting me down. No, there we go. The magic of technology, we will make this smaller, 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 smaller. Beautiful. Okay, so let's start by drawing a line down the equal sign. I like doing that when we solve equations. Next, take a look at the left side. Do you see any like terms we can combine? Hopefully you notice that we can combine 5x and 13x because they're both x's. Well, what's 5x's plus 13x's? 18x's. The plus 36 stays as is, and the equals 180 stays as is. We haven't done anything to that. Next, I'm going to subtract 36 from both sides. I'm going to do that because I want to get x by itself, and 18 is attached to x, but 18x is attached to 36. So I got to take care of that 36 first. So minus 36 because we had a plus 36 and we're using those opposites. On the left, I have 18x equals, what's 180 minus 36? It's 144. And then to finish up, do you remember which step we take? We divide by 18. Looks like I still ran out of space, but that's okay. I can draw a little arrow, and I can write that x equals, well, what's 144 divided by 18? It's 8. Awesome. Let's take a look at number 6. There we go. Okay, well, number 6 says, if the measure of angle RQT is 136, determine the measure of RQS and SQT. I think I meant to write to find the value of x. That's okay. Let's do that. Well, let's do both, actually. I don't remember how I did it on the answer key that I have at school. Let's check it out. All right. So if that whole angle is 136, that means I can add the two angles and get 136. All right. Well, I'll add angle RQS plus the measure of angle SQT to get 136. Okay, let's substitute. RQS is 8x minus 4, and SQT is 4x plus 20, and that equals 136. Let's solve. The first thing that I'd like to do here is combine some like terms. Let me erase that pink that I just drew there. I didn't mean to do that. I meant to highlight in pink and highlight in yellow. Okay, do you see some like terms on the left? I actually see two pairs. I see 8x and 4x. I also see minus 4 and plus 20. Let's combine them. First, let's combine our x's. 8x's plus 4x's give us 12x's. Then we have minus 4 and plus 20, so negative 4 plus 20 is positive 16, so plus 16. And the 136 remains as is. What should our next step be? Let's subtract 16 from both sides. Okay, so we have 12x remaining, and it equals whatever 136 minus 16 is, which is 120. Excuse me. And what should our last step be? That's right. Let's divide by 12. And we get that x equals 10. Again, I don't remember if I changed the instructions on the copy that I have at work/school. So let's find out what both of these measures are. So I don't remember if I changed it to stay x equals or to find x or if we're still finding the measures. Okay, well, let's find what RQS is. Well, RQS, so the measure of angle RQS is 8x minus 4. We found that x is 10, and let's color code it. So really, that means we're doing, if it lets me zoom in, yay! We're doing 8 times 10 minus 4. And that, of course, goes straight into your calculator. I meant to highlight this, not cross it out. I think I'm going too fast, and the computer is lagging. That's okay. I shouldn't be rushing, even though I'm rushing. There we go. 8 times 10 is 80, minus 4 is 76. Now let's find out what the measure of angle SQT is. Well, SQT is 4x plus 20. X is 10, so let's substitute. 4 times 10 plus 20 equals 4 times 10 is 40, plus 20 is 60. And just to double check, is 76 plus 60 136 degrees? Sure is. Fantastic. Number 7. Number 7. For these two problems, let's write the congruent statements. So let's just write what's marked. Now, number 7, I see a side and an angle that's marked. I see this side and this side. Let's label them. I see AR congruent to YR. Great. Now let's name the angles. I see this top M angle and this bottom M angle. Because they are both angle M's, I can't just write angle M as congruent to angle M. I need to write 3 letters. So for the top one, I'm going to use these 3 letters. You can call it AMR or RMA. Doesn't matter. I feel like doing AMR. As long as M's in the middle, you're doing good. For the bottom M angle, I'm going to use these 3 letters. You can call it RMY or YMR. I feel like doing YMR. Either way would be correct. Make sure that M's in the middle. Number 8, same idea. We've got a side and we've got an angle. This time I decided to mark the side with 2. Doesn't matter. I just felt like it. I got side ZY. You could have called it YZ. Still correct. And I have side YM or MY. Doesn't matter which way you call it. Once again, I have 2 angle Y's, and I can't just say angle Y because they're part of 2 different triangles and they just happen to be connected. First, let's label this one. I'm going to use 3 labels to call this angle Y. Y should be in the middle. What should I name it? What do you think? You write it down first, and then I'll write it down. I'm going to call it ZYS. If you called it SYZ, you're also correct. Try naming this angle Y. I'm going to call it MYA, or you could have called it AYM, as long as Y is in the middle. Right. For the next few questions, we're going to determine whether these are congruent by side, 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 angle, side, whichever. We just need to show if they're congruent or not and write down the congruent statements. Number 9. In the figure below, triangle ABC and ADC are isosceles triangles with a base of BC and DC. And the angle BAC and CAD are congruent. First, I'm going to mark the bases of my isosceles triangle. I like doing this because it personally helps me see the I'm trying to erase this. It'll happen. There we go. It helps me see the isosceles triangle a little better. So base, base. Now what we know about isosceles triangles is that attached to the base they have two congruent sides and two congruent angles. I like to start by labeling the two congruent sides because those are easier to write. Now, if that's not enough information after we mark the other congruent angle we were given, then we'll mark the congruent angles. But let's see what we've got so far. In the triangle ABC, so this top one right here, I'm going to do a little dot here, it has two congruent sides attached to that bottom, this side and this side. Now in the triangle below it, right here, it also has two congruent sides attached to it. Now since AC already has one tick on it, AD should have the same tick because they will have the same measurement. Okay. Now let's label the angle BAC and CAD. BAC is this angle. CAD is this angle. Is that enough information for us to state that these triangles are congruent? I'm going to say yes. This is why. They both have a side, an angle, and they share this middle side. So they're congruent by side angle side. Let's write down the congruency statements. First, let's write down those two outside sides. We've got AB, which is congruent to AD. We also have the angle. It was given to us, so I'm just going to copy exactly what was typed. Angle BAC is congruent to CAD. And lastly, they both share the line in the middle. It's going to look kind of silly, but we'll write that AC is congruent to AC because they both share it, they both have AC. All right, number 10. All right, at number 10, I see two triangles. Each of them have two sides labeled 3 and 4, and then a tick on the third side. Well, let's check it out. Well, if they both have a side that's 3, a side that's 4, and a side that's some measure, well, then they're congruent by side, side, side. I gotta say this though, I know the measure of the missing side. It's 5. 3, 4, 5 is like the most famous triangle. This is actually the type of triangle that was used to build the pyramids before they even understood what right angles were. They knew 3, 4, 5, and they had like a rope with 3 knots, 4 knots, and 5 knots, and that's how they made sure that the pyramids were stable, and they're so stable they're still around to this day. Anyways, let's write down the congruent statements. I'm going to start with the 3 sides. On the triangle on the left, that's side AM, which is congruent to side GE. Next, I'm going to do the 4 millimeter side. Got AR, congruent to EO. Then let's do the tick side, which would be 5 millimeters. And that's MR, congruent to GO. Number 11. Let's see if these are congruent. Let's see what they both have. Well, they both have two angles that are labeled. Is there anything else that I could label? There is. That side in the middle that they both share. They both have that side. They're connected by it. So, these two triangles are connected or congruent by angle side angle. Let's write down the congruencies. Let's start with that one arch angle. Oh, what did I just do? Did I zoom out? I know I did. Hold on.